In our last section of Chapter 11, we're going to look at the relationships and the formulas between chords, secants, and tangents. So we are going to start off with our first one. Our first combination is if we have two tangent lines on our circle. So a tangent, tangent. And this means we have two tangent segments drawn from the same exterior point. Okay, tangent, tangent, two tangent segments drawn from the same exterior point are equal. So once you get that definition down, if we look over here, we have an exterior point from our circle. If we draw two tangent lines that both start from that point. So we have one that looks like this and one that looks like this. Remember, tangent means the line hits our circle at one point. So if we call this tangent line A and this tangent line B, in this case, when we have tangent, tangent, that means A is going to equal B. So if in our example we had something that looked like this, if we knew this part was 13 and this was x, we know that x equals 13 if those are both tangent lines. Our second combination is if we have chord, chord. And with chord, chord, this means that the product of the measures of the one chord equals the product of the measures of the other chord. Okay, so remember, a chord is a line that connects 2 points on a circle. So if we have a chord that looks like this and this, and we label the parts of our chord as C, B, A, and D. In this case, our product of the measures of one chord, so AB, A times B, is equal to the product of the measures of the other chord. So A times B equals C times D. So then if we look at an example, we have a chord here and a chord here. So it's 4, 9, 3, and x. We can use this formula to figure out what x is. So we have 4 times 9 on one chord, and that is equal to the product of the other two numbers on our other chord, which is 3 times x. 4 times 9 is 36. Divide both sides by 3, and we get our x value equals 12. Our next combination is a secant-secant. And in this case, we are going to have the whole thing times the outer piece. And that equals the whole thing times the other outer piece. So if we look at an example, a secant looks like this. It crosses the circle at 2 places and comes to a point outside the circle. So if we have this section is A, this is B, and C and D. So when we say the whole thing, we mean this whole secant. So we can write that whole line as A plus B, and we times the outer piece, which is B. B is outside of our circle. So that equals the other whole line, which is C times D. Sorry, C plus B, that whole thing, times the outer piece, which is D. So that is our formula for the secant-secant combination. So if we look at an example, here we have 2 secants. If this is 8 for x and 5. So we have the whole thing, which would be x plus 5, that whole secant, times the outer piece, which is 5, equals the other whole thing, which is 8 plus 4, times the outer piece, which is 4. We can distribute that 5 up above, so we get 5x plus 5 times 5 is 25. And then 8 plus 4 is 12, times 4 is 48. Subtract 25 from both sides. We get 5x equals 23. And when we divide both sides by 5, we get x equals 4.6. Okay, let's look at the next combination. Our next one is a secant tangent. In this case, we're going to have the whole thing times the outer, and that equals the tangent squared. Okay, so if we draw our secant here, and then we have a tangent line. Remember, tangent only hits one point on our circle. So we have A, B that make up our secant, and then our tangent is going to be line C. So our whole thing, our whole secant, A plus B, times the outer piece, which was B, equals the tangent squared. So our tangent is C, so that equals C squared. So we have a plus b times b equals c squared. So if we have our example over here, let's draw a secant across and a tangent. Okay, we have our secant and our tangent. If this piece is x and this piece is 8 and our tangent is 12, we can plug those numbers into our equation. So we have our whole thing, x plus 8 times the outer, which is 8, equals our tangent squared, which is 12 squared. Distribute our 8x plus 8 times 8 is 64, equals 12 squared is 144. Subtract 64 from both sides. Get 8x equals 80, and we divide by 8 on both sides. We get x equals 10. Okay, we have one more on the next page. Our last combination is tangent radius. And with our tangent radius, we have our tangent to a circle is perpendicular. Remember this symbol right here, the upside down T, that means perpendicular. It's perpendicular to the radius. Okay, it's perpendicular to the radius drawn to the point of tangency. So if we look at the picture, we have a tangent and a radius. The radius comes from the center, and those two lines are perpendicular. So all the tangent radius combination is saying that when you have your radius and your tangent, it is perpendicular to the point where that tangent line touches the circle. And then using that, we can create a right triangle here and use the Pythagorean theorem. And our Pythagorean theorem is a squared plus b squared equals c squared. We have our hypotenuse is c, and our legs are a and b. So if we look at an example, if we have a tangent here, a radius of 7, if our tangent line is 12, we want to figure out what that x is. We can plug those numbers into our Pythagorean theorem. We would get 7 squared plus 12 squared equals x squared. 49 plus 144, and that gives us 193 equals x squared. Take the square root to figure out what x equals. We get 13.9 equals x. In our last example, this is our given information. We have our radius is 6, our unknown is our tangent, that's our x, and it tells us that this piece outside our circle is 4. So if we know that we have a right triangle right here, we can use Pythagorean theorem. We just have to know this whole side, the whole hypotenuse. So if we know that our radius of our circle is 6, we know that this piece right here of our triangle is also going to be 6. And that makes our whole side of this triangle, the whole hypotenuse, 6 plus 4 equals 10. So if that hypotenuse is 10, our leg is 6, and we want to find our other leg, we can set up our Pythagorean theorem. A squared plus b squared equals c squared. Our a is 6, our b is x, and our c is 10. 6 squared plus x squared equals 10 squared. Get 36 plus x squared equals 100. And subtract 36 from both sides. X squared equals 64. When we take the square root to get rid of that squared, we get x equals 8. And that is our final answer.